Around you to the main hero after they started.
To be led something to.
Namaste. Good morning and a very warm welcome to Prayoga. I'm Alekha Acharya, an Education Research Associate at Prayoga. I invite Professor Y. Narahari, Shri D. N. Prahlad, and Dr. Tejaswini Anant Kumar to take their seats on stage. Professor Karandikar is on the way and will be joining us shortly. Today marks a significant milestone for Prayoga as we step into the world of mathematics education driven by our commitment to meaningful, inquiry-based learning. On this auspicious and special day in our journey, we are delighted to welcome all our esteemed guests and members who have gathered here for the unveiling of Dhatu. I would like to take a moment to express that we stand in deep gratitude and solidarity with the Indian Armed Forces, whose courage and dedication continue to safeguard our nation's freedom and spirit. Dhatu, a technology-enabled mathematics learning platform, is designed to enhance mathematical learning and problem-solving skills in students. Featuring comprehensive mathematics content built on the root question framework by Professor Jeffrey Woolman of Stanford University, Dhatu has been developed to build competence and confidence in mathematics through engaging and non-threatening methods. We are truly privileged to have with us today our Honorable Chief Guest, Professor Abhay Karandikar, Secretary, Department of Science and Technology, Government of India. As I said earlier, Professor Karandikar is on his way and will be joining us shortly. A sincere and warm welcome to all our online guests. Professor Jeffrey Woolman, Professor Emeritus of Computer Science, Stanford University. Dr. Ramana Yerneni, co-founder of Gradients. Mr. Murthy Valavetti and Mr. Alan Beck, also co-founders of Gradients. We sincerely acknowledge and appreciate you joining us late at night from across time zones. Your presence, despite the distance, unites us in spirit and shared commitment to this meaningful endeavor. It is a privilege for us to have our guest of honor with us here today. A warm welcome to Professor Y. Narahari, Honorary Professor of IISc. I request Shri Valish Herur to do the honors. Shri D. N. Prahlad, founder, Surya Software Systems Private Limited. I request Dr. K. S. Nagabhushana to do. Oh, sorry. It's Dr. Shri Valish Herur to do the honors. and Dr. Tejaswini Anant Kumar, Chairperson, Board, Indian Institute of Engineering, Science and Technology. I request Shri Abhay Karandikar to do the honors. We also have with us here today members from Prayoga's Advisory Board, Ethics Committee and Trust. As we commence, I seek the blessings of Chairperson of our Advisory Board, Padma Vibhushan and former Chief Justice of India, Justice Dr. M.N. Venkatachalaya. I extend a warm and sincere welcome to Advisory Board members and esteemed scientists, Padma Bhushan Professor P. Balaram and Professor P. R. Krishnaswamy. Ethics Committee Chairman Justice Krishna Bhatt. Ethics Committee members Professor Hemalata Balaram, Dr. Sridhara Murthy, Dr. H.S. Ganesha Bhatta and Dr. Uma Manjappara. And Shri B.R. Nagaraj, Trustee, joining us from the US. I extend a warm welcome to our foundation partners Zerodha, our CSR partners SEG, Deloitte and Merck, with whose support we extend learning solutions to schools across Karnataka, senior industry representatives from Kyndryl, OSAT and ExcelSoft, dignitaries from Vidyashilp Banshankari, Kadambi School, RV Group of Institutions, BASE and the Sports School, our donors who have graciously supported our endeavors, and guests, well-wishers and the Prayoga family participating today online. Our efforts towards meaningful impact are guided by the support and vision of Prayoga's management. A sincere and warm welcome to Dr. H.S. Nagaraja, Founder and Chief Mentor, Dr. K.S. Nagabhushna, Director of Research, Prayoga, and Shri Abhay Karandikar, Managing Trustee, Prayoga. And a wholehearted welcome to everyone from the Prayoga family gathered here. It is indeed a moment of pride and joy for all of us at Prayoga as we come together to celebrate the unveiling of a project that embodies research, collaboration, and innovation. As we embark upon today's proceedings, I would like to welcome Dr. H.S. Nagaraja, Founder and Chief Mentor, Prayoga, to speak. Dr. HSN is a distinguished educationist, visionary leader, and committed social entrepreneur whose career spans decades of impactful education and public service. Renowned for his pioneering efforts in experiential science education, he founded Prayoga to promote hands-on, holistic learning, breaking traditional disciplinary silos and encouraging scientific exploration among students. Beyond academics, he is deeply engaged in social initiatives. His enduring contributions continue to inspire educational reform and social responsibility in India. I request Dr. H.S. Nagaraja to kindly acquaint us with Prayoga and its vision.
Good morning and a warm welcome to all the dignitaries, invitees, Prayoga family members, and a host of well-wishers who are not seen directly, who have always blessed every effort in building this organization to its present stature. A good morning to all these people. Today is a very special day. Institutions are born and they have their own pathways for the contribution that the institutions want to do. But some days become very special. Prayoga is basically a research organization. Basically, research in education. times have changed and the traditional method of rote memory has not only become irrelevant, but that will be counterproductive and destructive for the future. Therefore, the team of trustees at Prayoga decided that we should be able to do transformation requirements in education through research and innovation. Nothing can change, particularly in the right direction, unless it is backed by research. Opinion does not stand for long. Therefore, in that sense, this has been groomed very carefully with the help of all the advisors and the trustees to be an organization to aim towards building the necessary infrastructure in terms of research ingredients so that India's education system undergoes a transformation in the right direction. That's the objective or the aim of this organization. It's also possible not in short-term studies. We have started with school education, started with science, but today is a very special day. I'll come to that towards the end. And anything that is done in short run does not give enough results to depend upon. Therefore, the programs that have started both as Kriya and Anveshana are long-term. Particularly Kriya is a longitudinal study extending a minimum period of 5 years. And this is actually not only done to study a set of students, it's spread across the demography in such a way all the social strata are met. And therefore, longitudinal study along with the spread that is chosen to represent the demography will be able to scale it for the national level and help the policy makers. That's the objective of this study. And also, research without really understanding what is the impact it is supposed to make in the society also does not make much sense, because research by itself is fine, but what does it lead to is equally important. In that sense, all the services provided by or all the involvement of Prayoga with all the schools has been at no cost, and 97% to 98% of the beneficiaries of these projects are getting it absolutely for free. And it is also the Prayoga's mission that not only till now but in future also the beneficiaries should not pay a pie of money into this institution. India never connected money with three things: education, healthcare and food. Food was never sold, medicine was never sold, education was never sold. Therefore, at least as symbol of the culture of this organization, Prayoga aims to stand alone as a testimony of our ancestral values. We work with students, teachers and a large number of institutions. Maybe from this month of May end or early June, Prayoga will have about 11,000 students across the state, predominantly from government schools. And the number of students doing Anveshana has risen from roughly 20 people to about 50 people, covering 8 states from across India this time. The beauty of today is, I think I should also start it with Mr. Prahlad. One day he said, "Are you doing anything in mathematics? Can we do something?" Mathematics threatens most people. Can we do something so that mathematics does not become one word I will borrow, not exact sentence. Mathematics should not be a terror kind of thing. So terrorizing mathematics should go and mathematics should become enjoyable. And then he suggested a project naming Professor Woolman as the originator of the idea. We immediately jumped at that idea. Prahlad, today we are seeing the result of your conversation, and it's a very special day because it's not easy. Somebody like Professor Woolman spending every week 1.5 hours with our staff, hand-holding, guiding them, evaluating every question, and today we have reached a stage where we have completed the mathematics learning content for class 9 based on the root question method, and today we are actually announcing that part, and this, in that sense, is an exceptional day in the journey of Prayoga. I think we started with science. Today we have entered mathematics as a day for celebration. I think we look forward for many more days to celebrate, so that Prayoga truly will become an organization to contribute to global knowledge in the field of education. Thank you very much. Namaste.
Thank you, sir, for that comprehensive and thoughtful articulation of our efforts at Prayoga. Dhatu is the collaborative effort of a team of dedicated researchers and educators who have skillfully crafted mathematics content that addresses key concepts in a way that makes mathematics engaging, non-threatening, and effective. Prayoga's team of researchers and educators have worked meticulously to anticipate common errors in the learning process and provide thoughtful, tailored hints that address every possibility. The team is ably supported in this effort by mathematics subject experts Professor P. Srinivas Shastri and Ms. Yamuna. The Dhatu project has, most importantly, taken shape through the team's close collaboration with a remarkable group of individuals whose expertise and guidance have been instrumental in its development. Their contributions, especially in shaping the root question method and supporting the pedagogical vision, have deeply influenced the program's direction and impact. We are honored to introduce the key visionaries behind this project, Professor Jeffrey Woolman, Dr. Ramana Yerneni, Professor Woolman introduced the root question method, a transformative pedagogical approach that fosters logical reasoning and inquiry-based understanding, shaping the future of meaningful education. At 82 years young, Professor Woolman has been the guiding force behind Dhatu, meticulously reviewing each question and providing invaluable guidance to our team. His dedication is so profound that we often discuss that he was more present in our virtual meetings than some of us were in person. It is an honor to have you here, sir. Thank you. A PhD in computer science from Stanford, Dr. Ramana Yerneni has led software development at top tech companies including Oracle, Yahoo, Microsoft, Google, and Amazon. He co-founded Gradients Corporation. As a core contributor to Dhatu, he blends technical expertise with a vision for inquiry-driven conceptual learning. His commitment to transforming education through technology and thoughtful pedagogy continues to guide and inspire Dhatu's mission. Professor Woolman and Dr. Yerneni are both joining us from the US, where it is already quite late in the night. We are truly delighted and grateful to have you here, sacrificing precious sleep for the greater good of mathematics. That's dedication at its finest. Mr. Murthy Valavetti, an IIT graduate and tech industry veteran, co-founded Gradients Corporation, leading its software development and operations. With over 4 decades in software engineering, he champions tools that foster deep understanding in STEM education. His contributions to Dhatu underscore his dedication to advancing educational technology. Mr. Alan Beck, co-founder and chief software architect at Gradients, brings 3 decades of experience in software development across Tandem Computers and Teradata Corporation. An expert in transaction processing, ephemeral computing, and efficient provisioning, he holds MS and BS degrees in computer engineering from the University of Illinois at Urbana-Champaign. I now invite Professor Jeffrey Woolman and Dr. Ramana Yerneni to introduce the root question method and highlight its relevance in mathematics education.
Okay, thank you. Ramana, do you want to say something first? If so, unmute yourself.
With your presentation, and then we'll do some Q&A at the end.
Okay. All right, let's... Okay, I hope everyone can see the slides now. Is that correct? Wait. I don't know, because I shared. Can you see it now? Murthy is shaking his head yes. Oh, okay, good. Okay, still see them now? Good. Okay. Anyway, I want to thank what is undoubtedly a very impressive group of scholars for attending this this meeting. I want to tell you a little bit about Gradients technology. The key point is that we wanted to make homework, well, take away the responsibility of very mechanical grading from the teachers to give them more time to help the students who are struggling or enrich the course for students who are doing well. At the same time, we found that we could embed part of the teaching process into the homework itself. Well, as I guess has been mentioned before, the solution that we came up with is called root questions. So I want to basically talk to you about that. Again, because as been said, it was developed by the 4 of us, and I want to make clear, the rumor seems to be going around that I invented this thing. It's just really not true. The other 3, Alan, Murthy, and Ramana, had designed and were working on, had implemented a great deal of the platform before they even talked to me about this. The patent, which by the way is now expired, it was so long ago, but the patent on the root question idea was, well, both Ramana and I, our names were on it. So we've been using it for really college level courses in computer science for, well, over 2 decades now. And it's used at a number of universities and institutes in India. Our largest class with over 1,000 students is actually at University of Cairo. Okay, so the 3 problems we were trying to address was this. First of all, the conventional homework where students, they go home, they solve some problems, they write up the solutions, hand in a paper. It just doesn't scale. That is, the work is proportional to the number of students. We feel we could, if we took some of the responsibility off of the teacher, we could free them up to do more important and frankly more challenging things. At the same time, we thought that we could make the homework part of the instructional process rather than sort of being a mini test. And when I use it in my own class, what I do is I basically tell them to work on it till they get work on it till they get 100. It only counts a little bit in the final grades, just enough to get them to actually do the work. But it's basically helping to teach them. And again, the third problem that we were very concerned about was that when students make mistakes, well, in a college course, it usually is a week before they get their work back. But even in a high school, it's certainly got to be 24 hours before they see it. Hello?
Jeff, quick interrupt. Are you advancing the slides? I'm only seeing the title slide.
Oh, gosh.
Okay. Others are able to see the next slide? Hello?
We are unable to see the next slide.
All right. Okay, I'm gonna wait. Okay, I am going to try sharing again.
Okay.
And I'm going to do my entire screen.
Yeah, maybe easier that way.
Okay. And now I have, okay. Now, can you see Y gradients?
Yeah.
Yes,
okay,
that's a woman.
Good. Okay, good. Very sorry about that. Okay, so these are the points I've made. And then, as I said, we offer the root question solution. And again, just sort of to argue a little bit further as to what it is we were trying to do. Obviously, conventional paper and pencil homework was the target that we wanted to replace. I assume everybody can see things that don't work now. I hope.
Yep.
Okay. The normal thing is you give the kids some questions to answer. They write the solutions down on a piece of paper. They hand them they hand the paper in. The teacher grades it, gives it back to them maybe the next day, it's a lot of work. The more students you have, the more work you have, and by the time the students see what mistakes they've made, you've sort of moved on to something else. You're covering the next day's material. Now, multiple choice questions, of course, are very easy to grade by computer, but we've been doing it for decades. The trouble is, when in an ordinary multiple choice question, you're much better off, in many cases, just looking at the, say 4 choices and not solving the problem, just figuring out which one looks right. And of course, you can't really retry a multiple choice question if you get it wrong, because eventually you'll get, by process of elimination, you'll figure out you'll eventually guess the right question. Automatic, there are automatic graders. It's tricky, especially, for example, if the answer to a question is a graph. You could write a program that identifies correct graphs and from incorrect graphs, but it's very tricky and a great deal of work for a single question. Even if the answer is a number, I'm going to give you an example. In the middle of the answer is x equals 2.5. But there are many ways. I've just put on the slide a couple of the ways that you might write 2.5, and so even that to do that by computer, to recognize all the expressions that evaluate to 2.5 is a little bit tricky. So we avoid this. The root question, as I say, gives the advantage of multiple choice in that it's very easy to grade, but it doesn't have the disadvantages in that, first of all, students really have to work the problem just as they would in in conventional pencil and paper questions. Moreover, unlike the 24-hour or 1 week feedback cycle, they get immediate help when they make a mistake. Okay. And they can keep on working the same problem until they get it right. Okay. And again, it's all online. Okay. So here's what the student might see. Okay. It says solve the equation 2x plus 3 equals 8 for x, and then select the true statement about x from the list below. Now, I think everybody's already worked out that the correct value of x is 2.5. So now, knowing that, if the student has actually written down x equals 2.5 on a paper, they look at, well, x is an integer. No, it's not. X is greater than 6, not. X less than 3, yeah, it is. And x equals 5.5, no. So they can easily tell that they can tick off choice C. And obviously, this is now very easy to grade. C is right, everything else is wrong. But now suppose that they've made a mistake and instead chose D. That is, x is 5.5. Not, it isn't really. Well, then they're going to get a choice explanation that is appropriate. Again, remember, they were asked to solve 2x plus 3 equals 8. Now, I put x equals 5.5 as a distractor because a common mistake that a beginning student might make is, yeah, they realize they have to move the 3 over from the left side to the right, but they forget that they had to change the sign. If they forget that, then they wind up with 2x equals 11, and therefore might think that x is 5.5. So we would give them a hint that says, well, when you move a, you get to change the sign. That seems appropriate. Sometimes, we throw in usually some distractors that don't really come from anyway. So if they guessed x greater than 6, I have no idea why they're doing that. But we will just give them a more general hint, something that, for example, we might sort of start them off with the first step. Okay, start by moving the constant 3 from the left side to the right side. And by the way, don't forget to do it right. You got to change the sign. In either case, if they get the wrong answer, then they get a hint, and they're told, keep working on that problem, 2x plus 3 equals 8, and hopefully they'll get it right pretty soon. So when you develop a root question, it's a bit of work. We should not dismiss the amount of work that the Prayoga team has done on this. First of all, you write the stem, the question. You then have to develop several right choices. What this means is that the stem has to have a question that has more than one correct answer. You might think in mathematics that's kind of tricky because the whole story of mathematics is that there's one thing that's right. And then, of course, you have many wrong choices. We like to do at least four correct choices and at least 12 incorrect choices. And then, as I said, each of the wrong choices has to have an associated choice explanation. Often it's the same choice explanation for more than one incorrect choice, but we try to mix it up so that eventually, if the student's really having trouble, they'll see a lot of different choice explanations and eventually get the whole story. And then you have to write a complete solution, which should be available after the assignment is over. So again, the trick is you have to phrase that stem correctly. If we're just handing out an ordinary written homework, I would say, if 2x plus 3 equals 8, what is the value of x? But that only has one answer, x equals 2.5. But if you remember, the question that we gave, it said, solve the equation 2x plus 3 equals 8, and then select the true statement about x from the list below. And now the thing that again makes creating root questions tricky is you want to make sure that if they have the right answer, the student has the right answer, then all they have to do is look at the four choices, and it's very, very easy to tell whether a choice is correct. Okay, because again, this encourages students to actually work the problem as if they had to hand in the whole solution, because it's more efficient to solve the problem and then just pick out the one of the four choices that's correct. Now, in this case, well, x equals 2.5 is a possible choice, but we could have things like x greater than 2 or x less than 3, as we did in the example, or x is not an integer, or you can think of I think many other choices as well, each of which are true properties about the value of x. Now here's the problem. Again, we want to allow students to retry. The idea is if you made a mistake, we still want you to work on it and get the thing right. So now if they could retry the same, the same question with the same choices, well, they guess D, now they know D isn't right, so they're going to guess A, B, or C. Within 4 tries, they're guaranteed to come upon the right answer. That's a problem. But that's why we need to have many correct answers and even more incorrect answers. So they get the same problem. They're still working on 2x plus 3 equals 8, but they're going to get different choices. So if they've solved the problem again, doesn't matter what choices they have, they can very easily just look at the choices and say yes, yes, no, no, yes, no. Okay, and again, so this explains why we ask that the root question have a stock of both, many correct and maybe 3 times as many incorrect choices. Okay, but there's a little more to it, because even though we're throwing up different choices each time, we still, they can just, since they can try as many times as they like, they just pick something at random, and you have a 1/4 chance of getting it correct. They would eventually get it correct. Okay. So what we do is we bundle typically 5 questions at least in a homework, and we tell them that the objective is to submit the homework with all the questions correct. Okay. Now, 5 questions is enough. Well, if you work it out, the chance that you can get 5 questions in a row correct is less than 1 in 1,000. So guessing is not going to work. Okay, they really have to solve the problems. Okay, so that's it. Again, I think the properties that we like about root questions are, first of all, students are, if not forced, they are really encouraged to solve the problems just as they would in a conventional homework. On the other hand, they get immediate feedback when they're having trouble, and they can, continue working on a problem just as if they had a private tutor that would just watch them and help them if they made mistakes. And of course, this all is done without human intervention. Okay, so I think that's the story, and I'm going to now stop sharing. And how do we do that? Oh, okay, stop sharing. Okay, you should be back now. All right. Okay.
Maybe time for a couple of quick questions if anybody has. And Jeff had given a similar talk at last year's EDM conference. So there may be a video of that available also, maybe a longer talk. Yeah, go ahead. There was hand raised. We are not able to hear audio.
Just
How about giving some answers, correct answers, some incorrect answers?
Still rather low. We still not able to hear.
Can you hear me now?
Faintly, yeah, but somebody could repeat maybe in the Teams session, but go ahead.
How about including some correct answers and some incorrect answers? All right. And we ask the students to pick only the correct ones. And any incorrect answers chosen will entail negative marks. We can decide quarter mark or whatever. How about this?
I'll repeat the question, Dr. Yen.
Yeah, go ahead.
Yeah, I think you're better. I did not hear that at all.
The question was, how about including some correct answers and some incorrect answers? We asked the students to tick only the correct answers, and we include a negative marking component for the incorrect answers. Did I get that right? Yeah, that's the question.
Yeah. In fact, we do have that as part of the
standard feature. When you assign a homework, you get to decide for each correct answer how many points you want to give, and for each incorrect answer how many negative points you want to give. Mm-hmm. So that's something that the teacher can decide on a per homework level.
Yeah. Well, actually, I heard more. I think the example the speaker might have been thinking of something like this: which of the following are primes? Okay, and then you might have a list of 10 numbers, 5 of which are primes and 5 are not. We could do that. We have not. Again, our design, I guess, has always been, let's just do the simplest thing that works. But it probably would not be too much trouble to offer that kind of question.
Yeah, so you're saying multiple correct choices displayed.
Yeah. Yeah.
Okay. Yeah.
Mm-hmm.
I apologize, sir. In order to stay on schedule,
Yeah,
any further
yeah.
questions can be addressed after the event.
Exactly.
Exactly.
Yeah, there's also a chat. If you want, I will look at the chat if somebody has some questions that they want answered now.
There's also a demo
Later in the day.
that might give a chance to discuss further. Okay, thanks.
Definitely. Thank you, Professor Ullman and Dr. Yerneni, for that insightful introduction to the root question method and its potential to enhance conceptual learning in mathematics. I would like to take this opportunity to welcome our chief guest, Professor Abhay Karandikar, Secretary, Department of Science and Technology, Government of India. I request Dr. H.S. Nagaraja to formally welcome Professor Karandikar. In recognition of this meaningful step forward in Prayoga's journey, I request Shri Valli Sherur, Managing Trustee Prayoga, to introduce the purpose of Dhatu, an innovative initiative in mathematics education.
Distinguished guests on the dais and all the well-wishers and eminent people here in the room today. I take this opportunity to welcome everyone once again to this event. Essentially, as HSN mentioned earlier, Mr. Prahlad had a discussion with us about how mathematics is something that students get overwhelmed with very easily and very early in their learning careers, and after a point of time, mathematics is something that they would want to run away from. So his very sincere concern was, how do we change that, and how do we change that in the Indian learning context? So that is how we had a discussion with Professor Jeffrey Ullman and Dr. Ramana, and the whole journey began. So we've been working on this for about 10 months. In the last 10 months, we have created the content for grade 9, etc. And we are the event today is to announce this and take it to the pilot phase, which would begin in the academic year 25-26. So essentially, the ideas, traditional methods, no longer serve the entire student spectrum, and that is where a method like root question method could be adopted and could help a larger set of students than what we currently are able to do. It also, as Professor Ullman was saying, it is like a tutor looking over the shoulder and guiding the student at each step to be able to strengthen the conceptual understanding and the problem solving skills associated with math. So essentially, learning system where math feels supportive and not a threatening learning program. So that is the objective. And why are we trying to do this as part of Prayoga, as a research organization? So at Prayoga, we want to see how better pedagogies and methods could be brought into the teaching learning systems in the Indian learning context, and also understand what kind of impact it would make, because the evidence that we could get from students and teachers teaching and learning this way will point us to what is the impact, what is the kind of change that this brings about. In this specific case, in terms of understanding of mathematics, it could be in terms of various competencies of mathematics that the students need to acquire with time. So the overall objective is to see how we can enhance mathematics learning, and we are trying to see how we can do it through a layered approach. From a research angle, we would be working with schools, students, across the socio-cultural spectrum of the country. So we would be working with government schools, private schools, individual students, etc. When the condition that Professor Ullman and Dr. Ramana and the Gradients team put forth was, we would be willing, they said that we would be willing to share the idea of root question and also give the platform, the technology platform that they've evolved, under the condition that it would be used for a non-commercial purpose, and that fitted extremely well into the way Prayoga does. So this platform and the content would be made available to students, teachers and schools going forward at no cost to them. And it can be pan-India, and that we believe is a significant reach that this platform could have. So when we work with students, a large number of students across the socio-cultural spectrum, we would be able to understand the patterns of mathematics learning and also the competencies that students are able to demonstrate at a very granular level, and which is data that we believe in the country we don't have. So from a that would be a very fundamental data for us to improve on the curriculum and the content that we eventually get students to go through at the school level. And since this would be made available to a large number of students, schools, teachers across the country, I think there's a significant social impact that could come out of it, because extremely good content today is available at a price which to a large section of the society is unaffordable yet. And to be able to provide high quality learning content accessible, available to even the student in the remotest corner of the country is something that we believe will add significant value to the society as well. So Prayoga as such combines research and social impact, and even in the Dhatu program we aim to be able to achieve that. So the roadmap is, we would the 25-26 academic year would be a pilot where we would make available content for grade 9 and grade 10 to select set of schools that with whom we would do the pilot. And the 26-27, I think we will be ready with the entire content for the 4 years, 4 grades, and it will be open to schools as well as individuals to be part of. From what would be available and what is it that we are trying to do? We are working in the grades 9 to 12, the high school grades, where the content would be aligned to the NCERT curriculum or the syllabus. We are trying to build content in 3 layers. The first layer is where it would meet the school or the board requirements as defined by the NCERT. The second layer typically could become a little more analytical and kind of cater to the competitive examinations that currently are prevalent, that most students end up taking. And the third layer would be for those who really enjoy mathematics, who want to push the boundaries, typically those students who take Olympiads and things like that. So we are trying to build the content in 3 layers so that we are able to cater to the diverse spectrum of students interested in mathematics. It will be a technology-based platform. Therefore, the student would be able to track his progress. A school would be able to track the progress of the learning of a student, and also the teachers would be able to customize the learning content and the questions for the students based on their abilities. And from an education research perspective, we would be able to understand the learning behaviors in students and be able to gather data that indicate the mathematical competencies acquired and demonstrated by Indian students across the socio-cultural spectrum. And I'm happy to introduce the team that is already working on this. We have the academic excellence team members in mathematics, Mr. Ramana, Yamuna Natraj. She's not been able to join us today, but she has been contributing significantly. Professor Srinivas Shastri, and said a very enthusiastic young mathematics enthusiasts, Krishnan, Vanilla, Neelambika, Hedi, Lalmanga, and Nandini. From the education research team, we have Dr. Karuna, Shubhashri Patnaik, Alekha Acharya, and Manaswini, who are part of this project. And again, I need to present the gratitude to the Gradients team, who have been extremely forthcoming and providing all the support to Prayoga in taking the ideas that they have conceptualized and use their technology to be able to build this platform for this country. Thank you.
Thank you, sir. This is truly a pivotal moment in our organization's history, our first international collaboration with such eminent mathematicians and educators to transform mathematics learning in our country. We will now unveil Dhatu with the auspicious lighting of the lamp. It is in our tradition to light the lamp before new beginnings, to invite the divine presence, promote positivity, and welcome knowledge over ignorance. I respectfully invite our chief guest, Professor Abhay Karandikar, Shri D. N. Prahlad, Dr. Tejaswini Anand Kumar, and Dr. H. S. Nagaraja to kindly come forward and light the lamp. Professor Y. Narahari as well. I request Professor Abhay Karandikar to unveil the Dhatu logo. The Fibonacci sequence is a beautiful example of how math appears in nature and everyday life. Our Dhatu logo is inspired by this pattern to highlight that math isn't just numbers, it's about patterns, growth, and connection. This reflects the heart of our Dhatu initiative, making mathematics meaningful and alive. I request Shri D. N. Prahlad to unveil the collateral for Dhatu. The unveiling of our new initiative, Dhatu, nurturing deep conceptual understanding of math, marks an important milestone at Prayoga, stepping into mathematics education research. Dhatu will be available to schools, students, and teachers across the country at no cost. It is an endeavor that is aimed not only at reshaping mathematics learning, but also making it more inclusive. We'd like to extend a token of our appreciation to our guests. We are honored to welcome Shri D.N. Prahalad, whose contributions have been instrumental to this initiative. Sir is the founder and chairman of Surya Software Systems, leading innovations in financial tech and AI services. A former independent director at Infosys, he played a key role in shaping its risk and strategy. Actively engaged in academia, he advises premier institutions and has received IISc's Distinguished Alumnus Award for his contributions. It is with great pleasure that I call upon Shri D.N. Prahalad to share a few words on the genesis of Dhatu.
First of all, thanks everyone. I'd like to begin by thanking Professor Ullman for the extraordinary talk last year. And he has more or less conveyed the same thing. Last year he took an integral and conveyed this concept to us. And this year it's y is equal to mx plus c. And I wonder what will it be next year. How much more simple can he get? Thank you, Professor. Thank you, Ramana. I haven't met Murthy and Alan. I've met Ramana and Jeff. I think they're extraordinary scholars. And I really thank you for coming down and helping children learn mathematics, which is, I can't believe I learned compilers and mathematics from the same gentleman. It's something, if I were to tell someone, they'll say, what are you smoking? Right, now, here asked me about, Varlish asked me to talk on the genesis of Dhatu. It's a very long story, you will be here all night. But I've always classified myself as a victim of bad mathematics teaching. Till I entered the Institute of Science. That's a different story. That's Professor Y.V. Venkatesh who taught me what mathematics was all about. So, why is the teaching bad? That is the key question that we have to answer. The teaching is bad because we do not teach the concepts of mathematics. It's a beautiful thing. It's a language which is unbelievable. 5 mangoes, 5 apples, 5 trucks, 5 airplanes, 5 stars, 5 planets are all reduced to one number called 5. Imagine a world when we didn't have the number system. How difficult life would have been. If you had 2 trucks to 5 trucks, it wouldn't work, right? So it's one of those most beautiful languages. In fact, I was telling somebody just now, the most powerful words I've heard in my life are let x be an integer. Now, I didn't have to write an equation for 5, 7, 9, 15, 13, 7, 17, 8, etc. It's just x. So the beauty of this language is never taught to our children. And I wanted to imagine a whole new way of teaching my own children, which I think I successfully did. And I'll tell you one of the examples was, I just kept asking my second son, what is 1 plus 2? 2 plus 1. 7 plus 5. 5 plus 7. And after the fifth one, he said, I know that. Next question you're going to ask me is this. And answer is this. I said, that's called commutative law. So that I thought was a lovely way of teaching a child. So bad teaching methods is the biggest motivator, Wallish, if you ask me I'm a victim, most of you are. I don't think anyone who has not had the fortune to attend maths classes in an Institute of Science, I think is a victim. I stopped being a victim then. Then coming back to India, what's our problem? Our problem is that we cannot use conventional methods. It's over. That, it's a country of 1.5 billion people. Even if you take some minuscule 10% as children go to school, it's a massive number. We don't have enough schools. We don't have enough teachers. Right? I think I did the calculation last year and conveyed it in the conference there. It's something we can't do. So how do we arrive at this possibility of education? It is only through technology. There is no way we can have a tutor for everybody. And everyone needs a tutor in the initial stages. So scale, which is absolutely required. Just to give you an idea of the scale of this country's, transactions. I was working on the GST project as one of the principal designers, and we found that what Hindustan Lever, there is one company uploads in 15 days as number of invoices, Australia does in 1 year. That is the scale of this country. It's unimaginably big. And all the solutions that we find somewhere else are not going to work. We have to invent our solutions. And I found the root question method that Professor Ullman, Ramana, and Murthy and Allen have arrived at as one of those that could definitely scale, because this eventually replaces the need for a tutor sitting next to you. It will be what I call an electronic co-tutor. These days everyone talks about co-pilots, and they're about co-tutors, right? I'd be remiss in not thanking the sponsors. I think it is Zerodha, Deloitte, I don't have the list, but whoever has given us the money to do this, extremely grateful to you. Please keep giving us more. We'll do good work. And then the last point, I don't want to take too much of your time. The other motivation was, I've met many people in my life. I've never seen someone who is good at mathematics not being good at something else. Is that your experience too? I mean, if anyone wants to contradict that, please do so. I think it'll be 1 in 500 million or something like that. I don't think it's a normal occurrence that somebody is good in maths but hopeless at everything else. Maybe he's bad at cricket, but not in other studies, right? So this, I think, was the major motivation for me, saying if we can gift our children a knowledge of mathematics, is the biggest gift we can give them. And therefore, I approached HSN and Wallish for seeing whether there is something we can do about teaching of mathematics. And if somebody had told me this would be a reality, again I would have asked them, what are you smoking? But today it is a reality. Thanks to all the people who have worked on this project. You have done an immense service to all the all the children of this country. And again, I'd be remiss in not wishing all our Army personnel, the Air Force and the Navy personnel, a safe return home. Thank you so much.
Thank you, sir, for shedding light on how Dhatu's journey began. It is our privilege to have Dr. Tejaswini Anand Kumar, Chairperson of the Board of Governors at the Indian Institute of Engineering, Science and Technology, Shibpur, Chairperson NIT Kurukshetra, and Board Member at IIT Ranchi. A distinguished engineer, scientist, and leader, she contributed to India's LCA Tejas project before co-founding the Adamya Chetna Foundation, which promotes sustainable living and provides midday meals to over 2 lakh children daily. This apart, she also regularly offers free lunch to a large number of underserved people. She blends technical expertise, social impact, and public service, making her a key figure in technology and civic leadership. Ma'am, we look forward to hearing your thoughts.
Elrigu namaskara. Dignitaries on the dais, all the dignitaries of the dais. It's an honor to me today to be here with such a wonderful historic program, Dhatu. Especially I am thankful to Dr. H.S. Nagaraj. It's Guru, he is Guru to many of us. It may be works related to Adamya Chetna or the academic work which I am presently involved, or it may be at personal family level. It's always I look up to him for anything, and he's such a wonderful person who has created a wonderful Prayoga, which is no longer a Prayoga, which has been, he has proved it that it is possible to do this, and I am thankful to him, and I congratulate Prayoga for its unwavering dedication to the nation building through education. Since its inception in 2015, Prayoga has demonstrated how evidence-based solutions and contextual innovations can transform teaching and learning, especially in foundational subjects like mathematics, chemistry, and physics. As someone who has worked very closely with grassroots communities through initiatives of Adamya Chetna, especially Anna and Akshara and Arogya areas, I have seen, it's been my first-hand experience how any small intervention can really bring in a big change. The midday meal program, 1 meal in the afternoon, just rice and sambar, has really brought in such a big change in the schools. We can see the percentage of passing, the toppers marks in many of the schools where we are working in Bangalore, Hubli and Kalburgi, and even in Jodhpur in Rajasthan. And I still remember this was just before we started midday meal program of Adamya Chetna in 2001 and 2002. We had adopted a couple of schools in Bangalore, and one of the first high schools of Bangalore, Sultanpete Ganesha School. I think many of us know about that school. And in that year, there was no mathematics teacher for SSLC. Just imagine, for SSLC, the teacher was on a long leave. So we decided our volunteers will go and teach whatever we can recollect what we studied, and basically the more of a conceptual teaching. Every Saturday our volunteer, and that was my elder sister who always loves mathematics, she used to teach all of us, me and my brother Pradeep, who is here today with us. And that intervention of every Saturday, Chaya going to the school, and the average passing in that school used to be 28%, 28 to 30%. That year it was 75%. That's a big change. That fear for mathematics, that went off with her intervention and the kind of teaching. And those are many such things I keep seeing in the school level, and that has been demonstrated by Prayoga in chemistry, in physics now, in last few years. And I think Dhatu is a timely and much needed step in this direction. And mathematics, like in Kannada we say, it has been always kabbinada kadale. It is a steel nut which is very difficult to crack. Even the spelling mathematics, I remember coming from Kannada medium, we used to say MAT, he, MAT, ICS. Remember ICS, one of the most difficult examinations those days. And maybe by hurting those formulas, the prameyas, the theorems, it has been, very scary subject for many of the students. And I was saying prameyas are the theorems. I studied in Kannada medium. And now there is, with Dhatu, there is no prameya. Prameya is the requirement in Kannada. No prameya of remembering prameyas, I think. We can, so the Dhatu is providing that platform of, which is really empowering. It makes maths accessible, engaging and meaningful. And by applying the root question method developed by esteemed Professor Jeff Ullman, it shifts the focus from memorization to understanding and from fear to curiosity. I am especially heartened that Dhatu will be freely available to the students, and again the even Adamya Chetana's slogan of Anna Akshara Arogya we should be able to reach out to all. Money should not be it should not be a factor at all, and I am so happy that such a high-end education pedagogy is going to reach the districts and the rural areas, reaching the girls, boys, studying in Kannada medium school, aided schools of villages of Karnataka and other states. And as India moves confidently towards vision of Viksit Bharat 2047, I was always wondering, with such a huge population, with so many issues, so many things, do we able to really do that, become a developed country by 2047? I was thinking 2047 is, should we, whether we will be able to see it. But after seeing Prayoga's achievements in last 4 years, I am very closely associated. In fact, me and Dr. H.S. Nagaraj, we keep talking at least twice, thrice a week. And after seeing that, I am now feeling, and after Dhatu and many of the achievements of our young students, I feel now 2047 is a long period. I am sure we will be able to do it much before. And that is the beauty of this intervention, which is happening in just small area compared to the large population of this country, the vast area, so many big institutions working. But this Prayoga has shown the whole world, whole country, that yes, these things are possible, these interventions will bring in a big change in the country. And let's unmask the mathematical talent hidden in every child. And today we have a wonderful guest who is heading the science and technology of the country. And now that Dr. H.S. Nagaraj has reached Prayoga's mathematics, now mathematics also will get into the new pedagogy, will get into schools. Already chemistry, physics has reached corners of every district of Karnataka. And I request Dr. Abhay Karandikar, my request is, please take it to different states of this country. Let every child of this country get this benefit, this new pedagogy, where the children, our young children, just can't imagine. Even people, professors of my age are not able to even publish our articles at international journals, but our young students, the students coming from government school, are able to do it. This is the big change. And lastly, today is Gurudev Rabindranath Tagore's birth anniversary, and today Dhatu is now showing the new dreams of learning without fear, mathematics without fear. And Rabindranath Tagore said, where the mind is without fear, the head is held high. Into that heaven of freedom, let my country awake. Thank you. Vande Mataram.
Thank you, ma'am, for your kind words. We are delighted to have our guest of honor, Professor Y. Narahari, Honorary Professor, Department of Computer Science and Automation, IISc, and member of the Advisory Board at Prayoga. His research specializes in applying game theory, mechanism design, and machine learning to problems at the intersection of computer science and economics. He is also exploring the application of game theory, computational social choice, machine learning, and data analytics to digital agriculture and public health platforms. His leadership and contributions have had a lasting impact on both the academic and technological landscape at IISc. Sir, we would love to hear your thoughts.
Thank you very much for providing this privilege and opportunity. Professor Karandikar, Mr. Prahlad, Madam Tejaswini, Professor Balram, Professor Nagaraja. I think this initiative of Dhatu, congratulations to the Prayoga team. You are best positioned to launch this initiative. Congratulations to Professor Nagaraja and the entire Dhatu team for this wonderful initiative. Just now Mr. Prahlad said he is a victim of bad teaching of mathematics. I would like to say I am actually a beneficiary of very good teaching in mathematics. When I was in high school, I had professors like Professor Lakshmi Narayana, Professor Vidyasagar, and in National College Gauri Bidnoor, during my PUC and BSc days, I had 3 lecturers, Professor S. Balachandra Rao, Professor G.K. Ranganath, and Professor Nagaraj. And when I came to IISc, I had Professor Vittal Rao, Professor V.G. Tikekar, and so on. So I'm really a true beneficiary. Not only myself, I think my son is also a beneficiary of this. Way back in 2007 to 2010, my son Naganand, he enrolled for the base foundation program run by Professor Nagaraja. And I think until that time, he was actually studying in the Himanshu Jyoti Kala Pitha in Malleshwaram. Mathematics for him was mostly like a rote learning. I think during his 9th standard, 10th standard, 11th standard, and 12th standard, it was actually game changing for him. It was helpful for him during his CET exam, for this so-called AIEEE exam. Later on for his GATE exam after his BTech. And it was also very useful for his PhD interviews at IIT Bombay, IISc, and so on. And it continues to be useful for him when he's writing papers in his research career. I think this is a wonderful experiment. And in 2023, we had organized EDM 2023 Educational Data Mining Conference. And we had invited Professor Jeffrey Ullman for that conference. He actually gave the keynote talk at IISc. And in his talk, actually, he talked about gradients corporation. This was a talk where he said the root question method in mathematics can be a game changer. But he also said, the gradients corporation, when it was started, it was one of those failed startups. However, I think it was also an inspiration for so many future startups which actually became very successful. And it's also an inspiration for the Dhatu program in some sense. So I must take some infinitesimal credit for introducing Professor Ullman through the EDM conference at IISc. And I'm glad that Prayoga has actually taken from there and made it a reality here. I'm sure this is one program which I think Prayoga is best positioned to do. They have done wonderful initiatives earlier. I have been looking at some of the initiatives for the last 1 year. I'm really impressed by the Kriya initiative that they have. So I think such initiatives only Prayoga will be able to actually make them very successful, and very glad that Prayoga has actually taken up this initiative. It sure is going to be a success, and I hope this platform will be useful not only to the teachers and students, but also to the parents and the grandparents who actually teach mathematics to the students. So I think, wishing all success. I hope Dhatu will scale up to the national level. And thank you very much again for this opportunity to talk here. Thank you.
Thank you, sir, for your insights. Indeed, we hope Dhatu scales up and continues to help generations to come. We are delighted that on this August occasion, we have with us our Honorable Chief Guest, Professor Abhay Karandikar, Secretary, Department of Science and Technology, Government of India. An esteemed engineer, educator, and administrator, Professor Abhay Karandikar has been serving as Secretary of the Department of Science and Technology, Government of India since October 2023. Formerly the Director of IIT Kanpur and a key academic leader at IIT Bombay, he has played a pivotal role in shaping India's tech ecosystem. A founding member of Telecom Standards Development Society of India, he was honored with the IEEE Standards Medallion in 2016 for his work in telecom standards and policy. His career is marked by a deep commitment to innovation, scientific progress, and national technological advancement. Sir, we are eager to hear your perspectives on Dhatu and its potential to impact education.
Thank you very much, Dr. H.S. Nagaraja, Professor Balram, Dr. Tejaswini, Mr. Prahlad, Professor Narhari, all the distinguished guests, advisory board members of Prayoga Institute, and all the members of this unique experiment, as it is called, and as I think Dr. Tejaswini mentioned, that it is no longer an experiment but is now maturing into an institution. So my heartiest congratulations for making this experiment extremely successful. I'm delighted to see that through your various activities, the Foundation has established a commendable legacy in driving innovations in educational research and setting up really a model for the entire country to follow in school educations. Particularly it is in the area of STEM educations, and today, for example, more especially in the mathematics. As a matter of fact, as you know that recent national surveys and carried out at various levels have shown that more than 80% of the students in our schools at the levels of 7th and 10th, they experience some kind of fear and anxiety towards the mathematics. And this is somewhat distressing to note in a country like India, where mathematics was really the foundation, centuries ago. And, look at the pioneering work done by Aryabhatta, who introduced really the sophisticated methods for solving quadratic equations, calculating square and cube roots, and even approximating the pi with reasonable accuracy. And as you know that Aryabhatta also proposed a heliocentric model for planetary motions using trigonometric methods. So we have the legacy of Aryabhatta, we have the legacy of Brahmagupta, and not only before that, even if you look at the Indus Valley civilizations, that has demonstrated a significant mathematical thinking through very precise urban planning, and more importantly, standardized weights and measures which were there, and finally in the geometric designs that was there in the town planning and architecture, that demonstrated a deep conceptual understanding of the mathematics when rest of the world was really grappling with the scientific traditions. And therefore it is somewhat of a great concern that in our country school children are actually having some kind of a fear or anxiety. Not only that, in our school educations, particularly at the high school level, we have introduced for years we have introduced some kind of a system where after the primary or secondary school, for high schools, you either choose mathematics or you choose biology. And this division actually created two sets of students, one who were devoid of complete mathematics educations were only learning biology, and one who were learning mathematics but did not know anything about the life sciences and the biology. And as you know today, that all research which is happening is more and more at the intersection of all the scientific disciplines. There is a significant amount of mathematics now being used in biology as well. So even those who want to go, for example, and become a biologist, or they want to become life scientists, they need to know a significant amount of mathematics. Also, the significant advancements that are happening in the technology world, particularly in the area of artificial intelligence and machine learning, the foundations is really, the core foundation is really the mathematical algorithms. Finally, I think even in the upcoming areas like quantum technologies or quantum computing, and more recently like cryptography or quantum cryptography, the foundation remains the mathematical learning. So as was mentioned by several speakers, particularly, of course, Mr. Prahlad mentioned about Indian Institute of Science, Bangalore, but I must say that since I studied in IIT Kanpur has also some very wonderful tradition of teaching mathematics, particularly in the electrical engineering. And I myself, although I did my PhD in computer networking area, many times it was told to me that for me, a packet is a point on the Poisson line. So that was, a packet in the computer networking until, I really blended the mathematical conceptual understanding with the networking protocols and finally, of course, in the wireless networkings. Now, one problem that remains in our country is, of course, the lack of excellent and outstanding teachers who can make the subject interesting. But another problem also remains, particularly at the school level, for the students to connect what they are learning with what applications and impact this study is likely to have. And therefore, this disconnect is actually creates some kind of a fear in the worst case, and some kind of a cynicism at the best case, where students think that they seem to be learning only for the sake of learning, and this kind of a learning is not likely to have any applications either in practice or in their life at all. In fact, this is something which not only is prevalent in the school educations, but also in college and even at the engineering education, where it is very unclear many times to the students that what is being really taught is actually having a lot of impact, is going to have a lot of impact later on in their career, whether they go for professional engineering or whether they go for any other field. So I think this connection, that many of these foundational principles form really the foundations and the basis of the entire education system, is something lacking, which actually is required by the teachers for motivating the students. As I think was also mentioned, that in a country of our size and scale, given the large populations and also given the large number of students, it is extremely important to have the technology enabled learning, and I should say that very little work has been done in our country in the technology enabled learning. Of course, we have used online teaching programs and the video lectures and so on effectively, but that is actually not just sufficient for the technology enabled learning. In fact, in order to get a classroom effect, sometimes as a teacher, I know that when I am teaching in a class, by looking at the faces, I can determine that what I am teaching is getting absorbed by the students or not, and then I can appropriately modulate or reteach the concepts if I come to know, or I can ask the question and then get to know. But many times in the technology enabled learning where it is not possible to get the effect of a classroom teaching, I think some extensive research is required to be done in terms of an online teaching, how to create modern tools, including the use of techniques of artificial intelligence, AI, etc., to see that we can create an impact of a classroom teaching in a technology enabled learning. So in this context, I would really urge Prayoga to do some kind of an experiment in this area to see that how we can effectively use the modern technologies to scale the education, not just in terms of providing access, but also in terms of creating an effect where the learners are feeling as if they are learning in a way they would have learned if they had gotten a one-to-one connect. And I think that is really a difficult and a challenging problem in the area of education research, and I would feel that not much efforts have been paid, and this can be done only in a country like India, where I think Mr. Prahlad gave an example of just to see what is the size of the problems that we are talking, that this can make a significant and profound impact. Finally, I think I would like to congratulate the Prayoga team for adopting a very innovative method and a platform like Dhatu. I hope that this platform can bring a bold new paradigm shift to mathematics education, which can blend the tradition, technology, and also its relevance for the students. My apologies, I was a bit late, and since I saw that the presentation of Professor Ullman only towards the end, but I believe that these kind of techniques will enable the students for getting the insights maybe in algebra or calculus or geometry, and I hope that the student will be able to use this platform with ease and use cases, and I think this institute can use this platform to organize some kind of a maths challenge or hackathons as well, in order to popularize these techniques and make it available to a larger population. Finally, I should say that the reforms in the school education is incomplete without keeping the teacher in mind, because I think the teacher is the most important element in any education system, whether it is in the school or whether it is in the university, and therefore I think we have to not only train the teachers in pedagogy and in conceptual understandings, but also in terms of providing some kind of a soft skills which involves motivating the students otherwise also in a off class fashion, so that the students can get enthusiastic and passionate about learning, because unless the students are passionate and enthusiastic, the subject alone will not be sufficient, and therefore it is really very important for training the teachers in making sure that they can arouse some kind of a curiosity in the students, a curiosity driven teaching, and motivational learning will actually enable to provide an impactful education. Finally, I would say that the unveiling of this Dhatu platform is not just the launch of a new educational platform, but I hope it becomes the beginning of a movement which can be scaled to make a much larger impact in the education systems in our country. This journey requires all of us, the educators, the scientists, the policymakers, the teachers and students to come together. As the Secretary of the Department of Science and Technology, although our department mostly focuses on funding transformative R&D at university and institutions level, in fact, the Department of Science and Technology is one of the largest extramural funding agency in the country today. We have about 60 to 70% of the extramural funding comes from the Department of Science and Technology in our academic institutions. But we do have programs which work at the level of how we can improve the science education in schools, colleges and universities. And we would be really happy to see that how very unique initiatives which are carried out in different parts of the country can be scaled to make a larger impact nationwide. So thank you once again for making me a part of this journey. I wish you all the best, and I hope through these small initiatives taken throughout the country, with these drops can come together and we can make our nation a very strong nation in mathematics, which what it used to be centuries ago. Thank you once again.
Transforming the education system is an ambitious endeavor, and the support of stalwarts in governance and policy making is vital. Sir, your presence has certainly instilled a sense of confidence in our vision and efforts. Thank you for your valuable insights and support. I now request Dr. K.S. Nagabhushana, Director of Research, Prayoga, to deliver the concluding remarks for today's event.
Namaste. Dhatu in Sanskrit means root. The root question therefore has the name Dhatu, but for mathematicians it is .2. The reason for that is science is the first activity that Prayoga initiated. Learning science experientially is the first initiative, but whenever the second inning starts, it's called something 2.0. So instead of 2.0, there is a property, A plus B is equal to B plus A. So what is that property called, sir? Commutative property. So 2.0 is equal to 0.2. So the Dhatu. So that is how the name Dhatu has been fixated for this program. Thank you so much for attending this event. We really appreciate each and everyone for the time taken out of your busy schedule and being here. To start the vote of thanks, I would like to we extend our heartfelt gratitude to Professor Abhay Karandikar, Secretary, Department of Science and Technology, Government of India, for gracing this occasion amidst his busy schedule. His leadership and dedication to advancing scientific research and technology are remarkable, and his support in our initiative motivates us to do even more. We wish to thank the entire team Gradients, Professor Jeffrey Ullman, Dr. Ramana Yarneni, Mr. Murthy Valaveti, Professor Alan Beck, and Dr. Joseph Shodrek. It is now more than 10 months. Not a single person in this group has missed a meeting every week. That is the rigor with which these people have interacted and created something really strong for this program. Our guest of honor, we wish to provide our sincere appreciation to Professor Y. Narahari, Honorary Professor at IASC, Shri D.N. Prahlad, Founder Surya Software Systems Private Limited, and Dr. Tejaswini Anantakumar, Chairperson Board of IIEST. Your presence enriches this gathering. Thank you for your support and encouragement. We are really humbled by that. I would also express my gratitude to all the advisory members, but the ones who are present here, Professor Balram and Professor P.R. Krishnaswamy. We also wish to provide our sincere thanks to our ethics committee members, Justice Krishna Bhatt, Professor Hemalata, Dr. Uma Manjapara, Dr. Sridhar Murthy, and Dr. H.S. Ganesh Bhatta. Thank you very much for making it. We also wish to thank our mentors, Professor S.N. Hegde, who has come all the way from Mysore, Dr. Rangarajan. We also wish to thank our consultants, Professor R. Shankar, Professor Nayantara, VSS Shastri sir, Mr. Narayana, Ms. Archana Mittal. We also wish to thank the Dhatu mentors, Yamuna Murthy and Professor Srinivas Shastri. Namaste, thank you very much for your continued support. We also wish to thank our donor partners, Mr. Vaishak from VI Consulting, Mr. Om Prakash Jain from Zerodha, Mr. Sudarshan from Deloitte, thank you. The three people from the Merck, Rakshit, Dhanush and Ramnath, thank you so much for your continued support. We also wish to thank the guests, Mr. Dr. Pradeep Oak, who is also a classmate of Professor Karandikar. Friendship brings people together, yeah? Professor Samir Sima, Dr. Preeta Bhakta, Ms. Devi Prasad, Dr. Aithal, Mr. Vijeta, Mr. Rajiv Agarwal, Ms. Sita Lakshmi, Professor Yogananda, Professor Umesh, Mr. Sudhir of OSAT. Thank you so much for making it. Now the school partners, I also wish to thank Dr. Sudhakar Pai, Mr. Sudhakar Pai, who is the architect of this building. So if you want to construct anything like this, please talk to him. He is here. He's hard to find. It is very difficult, and he's so quietly sitting. He's a backbencher. Sir, I join you for mathematics class. I will be a backbencher like you. We also wish to thank all the people who have come from different schools. Dr. Sridhar from Diksha, Bala Subramanya also from Diksha, Dr. Maruti Girija Sonar and Dr. A.V. Shivakumar from BASE, Srimati Veena K.S., Srimati Rupa Pai from Kadambi School, Ms. Jaya Latha and Venugopal from the RV School, RV College of Engineering. Special thanks also go to the entire team of Prayoga, researchers, education researchers, mathematicians. These are the ones who, and they all don't think alike. There is one Sanskrit shloka, Upasargena Dhatuvartam, Baladanyasya Niyate, Prahara, Ahara, Samhara, Vihara, Pariharavit. The dhatu for all this is hru. So when it is connected with the upasargas, all these researchers at Prayoga, the meaning starts changing. Prahara, Ahara, Samhara, Vihara, that is the Parihara. So we thank all the researchers at Prayoga and the members of Prayoga for their continued support. We also wish to thank the trustee team, Dr. HSN, Walish, Dr. BRN is seeing us from the US, Praveen, and all the other trustee members. Special thanks to Mr. Sachin from Raman Research Institute. Thank you very much, sir, for making it so easy at the airport and coordinating the entire exercise. Ms. Gayatri Kurup from the Indian Express. Record and Media, the entire team of Murli. Logistic Partners, Stage 2 Event Management Team. Thank you so much, one and all. Have a nice time. Now the ahara is there.
I would request you to kindly stay back for a few moments. Please remain seated. I would like to extend my heartfelt appreciation to Professor Woolman and Dr. Yerneni, who joined us online. It was pretty late at night for them. Again, thank you so much, Professor Woolman and Dr. Yerneni. Your participation meant a lot to us. Dr. Murthy Valavetti as well. Thank you so much. Thank you all for being a part of this occasion. Our sincerest appreciation goes out to all who lent their support and made a meaningful impact on today's proceedings. Dhatu promotes better learning of mathematics, reduces teacher workload, and nurtures a culture of mastery and critical thinking, aligning perfectly with the goals of progressive, student-centered education. We look forward to Dhatu making a difference in mathematics education and transforming the learning experiences of students across India. We stand in solidarity with our Indian Armed Forces. As a mark of respect, let us now stand for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
With this, we conclude today's program. Kindly join us now for lunch. Post lunch, there will be a demonstration of the gradients platform, followed by a campus tour. Thank you, everyone.